Hi, everyone. Welcome to Lecture 3. Today we will be talking about California climate and temperature selection, specifically in Riverside and surrounding areas. It is one of the challenges of doing controlled environment agriculture in Southern California. We get so much solar heat load, and we're generally in a warmer climate. We're going to talk and focus a bit on cooling strategies today and looking more carefully at climate specifically in your area. My name is Dan Ovadia, your instructor for Advanced Controlled Environment Agriculture. This is in the Entrepreneurial Modern Agriculture Certificate Program at UC Riverside. So let's get underway. The goals for today's lecture are going to be the following. We're going to establish a crop and product concept. Remember, we want people to be thinking about their own business, their own farm, thinking about what is your product concept. It really should begin with what crop and what product do you want to deliver to the marketplace. We'll just briefly touch on that. The second thing will be to review and compare 3 different Southern California climates in your region so you can see the differences in just a short region, how big those site comparisons make a difference in terms of your crop target and your cooling requirements. We'll then calculate average day and night temperature deltas. That's the difference between the outside temperature and the crop target for strawberry, and then we'll rank those locations based on climate. And then number 4, we're going to just briefly go over some low and mid-tech cooling technology that are appropriate for California. So here we go. We're going to jump right into the product concept, and we've had quite a bit of questions around strawberry. I think it's an exciting potential crop. Riverside certainly has a history there. California has a huge history there, but keep in mind, most of it is focused on outdoor field production, and they do an outstanding job of it. However, think creatively, think ambitiously. There could be a nice market in the Los Angeles area for super sweet premium quality strawberry, and also having a high quality premium strawberry that is in that extended season. So that just means that when the field berries are in the marketplace, prices come down quite a bit, but prices are quite high, especially for a premium berry in the months where the field berries are not there. So that's what controlled environment can help you do, is extend the season on the front end, meaning getting earlier sweet strawberries, and extend it at the end of the season and getting sweet strawberries towards the end of the cycle. So again, in this case, think of your product concept here. It's a premium sweet ripe strawberry. Let's say we talked about extended season versus the field market. um, by all means, California has a tremendous number of genetics that could be suitable for your particular project. These are unique genetics that no one else is growing. We've talked about the Chandler berry, which is very, very sweet. It doesn't have a long shelf life, but it has amazing flavor. So that ties into the local strawberry concept. And then what's your value capture? A lot of controlled environment agriculture is very low margin, but think about, premium kind of value capture strategies like farmers markets in urban areas and restaurants, high-end restaurants that want very high quality strawberries. And then we can talk about lower tech CEA technology for this product concept. That's absolutely fine to go with a low capex, low opex strategy in this case. And then we'll set the day temperature target for this concept at 84 degrees and the night temperature target at 60 degrees. Cooler night temperatures are important for sweet berries and avoiding acidic fruit. We did cover this in fundamentals, but I just wanted to touch it again briefly about Köppen climate types in California. You can see the incredible diversity of climate in this region. Riverside is considered a hot and sunny inland valley climate, or a hot summer Mediterranean zone. That means hotter summer temperatures. You have a lot of natural light and irradiance. We talked a ton about light in the first 2 lectures in the advanced series, so we're going to leave that one alone, but just keep in mind there's a lot of natural light there, and that means a lot of solar gain and heat that contributes to the cooling challenge here. These inland areas can have lower land costs than the coastal zones, so you need to not just look at the climate in terms of ranking your location, but you need to think about things like land costs, energy costs, and the cost of labor as well. So, something we've mentioned in the past. So, in these hotter summer climates, yes, more investment will be needed for cooling technology, and there's really no way around that. You can, be very creative with different types of cooling system, but calculating the exact amount of cooling you'll need is really important to seeing if your location is feasible for the particular crop you want to grow. So again, what we want to do now is estimate temperature deltas. That's the difference between the outside temperature and your crop target. So again, you're looking at that climate by crop target interaction. And we're going to look at three locations: a cool summer zone, which is Los Angeles; hot desert zone, Needles, which is far inland near the border; and then the Riverside area, hot summer zone. So again, looking at these average daily high and low temperatures for different regions is an essential step. And again, we do very detailed climate analysis for large projects, but as an entrepreneur, this level of calculation is something that everyone should be able to do, and that's part of what this lecture is about. Otherwise, if you rely on vendors to do this calculation, you may run into trouble. So consider it as part of your own diligence for your own investment, is being able to how to do this kind of calculation. And this is how it looks like. Really, what you want to start with is comparing those average monthly high and low temperatures across different locations. And I like doing it in different ways. We'll go into a table format, but a graph is a really nice way to look at first those average monthly high temperatures between three locations. So you have, as we mentioned, Riverside, Needles, and Los Angeles. Let's just simply look at those monthly high temperature differences. And again, it's just remarkable in how much difference you can see just at a very similar latitude as you move inland. And so you can see in January and February, there's not a great difference. But as you get into those May, June, July, August, September months, that's when you see a dramatic difference between these locations with an average monthly high temperature in July of 109 degrees in Needles. That's not even the extreme temps. You know it can get 119 out there as well. So we're just going to work with averages today just for the purpose of the exercise. So you can see there some of the differences. And then if you look at the low temperature is actually the minimum temperature during the 24-hour cycle during the dark period. So this is essentially the high day temperature, and this is essentially the low night temperature. And this is really fascinating as well because you can see that actually Riverside is quite favorable regarding night temperature, especially when you compare it to Needles. So it's quite similar to Los Angeles. That was a surprise for me when I did this quick analysis. So that is great news because cool night temperatures are so incredibly important for successful crop management across all crops because plants generally like cool night temperatures. They can handle some heat and bright sun during the day, but cool night temperatures are essential, especially for strawberry. So this is a graphic illustration between the three sites. Now let's think again about each site and looking at those average daily temperature deltas. So here is a table form of what we just looked at: Riverside, Needles, Los Angeles, by month, average monthly high temperature or daily temperature. And again, here's our temperature target for strawberries. So all we're going to do is a simple calculation of taking your daily temperature target and subtracting the monthly average temperature. And then you come up with a table like this. And so we're just carrying across these numbers using this formula. And just at a high level, what I want you to think of is this: the negative numbers are how much cooler inside your greenhouse facility it needs to be than the outside temperature. So that's called a cooling delta. And again, this doesn't take into effect solar gain, solar radiance, and many other factors. This is the purpose of explaining how to calculate a day temperature delta or difference. So, right, if you do this calculation across the three sites, you see pretty significant differences, especially in the warm season. Again, the larger the negative number, the more cooling you're going to need. And so you can see Needles, obviously the warmest location, you're going to have much more cooling capability, minus 20 degrees, minus 25 below the outside temperature. Riverside is moderate. These look reasonable to me. I think with the right design strategy, you can achieve these cooling numbers even in the middle of summer. And then you see Los Angeles, which is just really, really fascinating at how much coastal influence there is. Just I don't know if it's 50 miles from Riverside, but this is why Los Angeles land is so expensive because of this ideal climate. So the other thing to just quickly look at here is for your day temperature target of 84 degrees, you're going to have to do more heating in different locations, though that's not as big of a difference between sites as the cooling difference. So think about that. Again, in wintertime, you're going to have to add some heat. Um, on a cloudy day, for example, when the sun is not out. And that's when you're going to have an increase of 15 degrees, 19 degrees, or 16 degrees, depending on the location and a few other factors, of course. But yeah, I really want to focus in on these deltas right here and the very significant differences between the three sites. The next thing is to look at the average night temperature delta. So again, here we're pulling the low temperatures, which are the night temperatures for each location. You can see there's no site that's even close to freezing temperatures, but you do see some differences here. And then our night temperature target is 60 degrees. And so again, you do the same exercise where you take your crop target of 60 degrees and you subtract your monthly average temperature, and you come up with a table which shows you your night temperature delta. Same thing here. Negative numbers means cooling. That's how much you will need to cool during the night to achieve your 60-degree temperature. And then you can see again in the cooler months, to get to 60 degrees, you're going to have to heat and add temperature. But focusing again on the warm part of the year, it's a very dramatic difference between Needles and Riverside and Los Angeles. And again, here's what we see graphically, that Riverside and Los Angeles are actually pretty similar when it comes to night temperature deltas. So really, really actually interesting for me just to see this. This is absolutely a major concern because cooling 17, 24, and 23 degrees at nighttime is a major, major challenge to do during the dark period in a very hot desert climate. And so, something we'll talk about a little later in the lecture, but this is how you kind of get a rough idea, estimate of which sites are suitable. And again, you can just put these side by side and look at your day temperature deltas, your night temperature deltas, just to summarize, um, and look at it. Which sites and how would you rank these sites? Well, I think the data is pretty clear, and that's actually the point of this whole exercise is to use data and not just use a vendor's opinion or your own opinion or your neighbor's opinion about where you can grow. It's to pull this data, look at the data, and make a very clear decision on ranking. And really, this is for strawberry. This is how I would rank the sites. Number one is going to be that Los Angeles region. And number two, pretty close behind, is going to be Riverside. I would actually rule out, and looking at these rough deltas without a more detailed analysis, I would rule out Needles as a location for indoor strawberry, simply too hot, both in the day period and the night period. Now, look, I know Los Angeles is quite expensive when it comes to land, However, when we're talking about smaller businesses, nimble businesses, lower capex businesses, it is possible to produce a lot of strawberries on even a half an acre. And so those are business concepts that really just need to be thought out and looked at and looked at very carefully. But at least from a climate perspective, we can see that both these locations have potential for indoor premium local strawberry. Now moving on to passive cooling systems and active cooling systems. I want to start out because we had some outstanding questions in our last discussion. Just want to focus on passive cooling because these are less expensive cooling systems and they can work really well in the cool months or in coastal climates. So you're going to be using passive cooling in maybe 5 months out of the year in Riverside or Los Angeles, and that is simply things like a roof vent. These can be manual or automated. Automated are definitely worth the money. And then you have these roll up walls or drop walls where you're simply dropping the outside wall and allowing all of that cool air in an exchange of hot air out. And you still get a tremendous amount of benefit from this roof, either protecting the crop or diffusing the light and making things more uniform. So passive cooling is certainly a very valid and well used technology, lower technology in Southern California regions and climates for different crops. Then evaporative cooling is something that is very relevant and powerful for California simply because we often have lower humidities, and evaporative cooling works well in climates with lower humidity because what we have here is basically what's called a cooling pad, which is a corrugated cardboard wall in which water is pumped to a header. It drips down across this cardboard, and fans pull hot, dry air through this wet wall and humidify it and essentially cool and humidify the air on the other side. In a positive pressure situation, this is done in a more precise way, and the cool air is actually distributed through what's called convection tubes. And so that cool air is generated and distributed through the greenhouse through these convection tubes. And this is a more advanced active cooling system in a mid-tech facility. You can see as well, there's a roof vent here too. So oftentimes you'll have some passive systems and you'll combine that with active systems for a particular location. And then finally, we did mention solar gain and radiant heat load, and that's why shade systems are very, very important in our climate. When you talk about challenging warm climates, there's so many different outstanding shade styles, but automated shade curtains are often made of high-tech aluminate or other products from the Netherlands, and these retract, and these can be deployed based on things like temperature and amount of light, and this allows you tremendous control, more control than what would be called a fixed shade cloth, where you're simply saying, all right, it's May, it's going to be hot and bright for the rest of summer. I'm just going to put a fixed 50% shade cloth in a nursery, for example, where you're starting plants. In this case, you're growing leafy crops. The fixed shade cloth also offers outstanding cooling gain and can help in combination with other systems, can help your lower tech facility achieve its crop targets with very little capital invested. So these are all systems from a company called Agritech, which is really, I would say, dialed into the California climate and have developed a number of systems specifically for California. And that's one reason why I'm highlighting Agritech here. So to conclude, looking at California climate and temperature selection, of course, inland Southern California is mostly comprised of hot summer and hot desert zones. We talked about that, and the challenge being cooling. That is the primary challenge, and there's a variety of low tech and mid tech greenhouse systems that can help you maintain temperature from those warm months. Generally, they're May to September. And then the next thing really want to think about is once you've established your product concept for your farm and for your crop, then you want to look at those average monthly high and low temperatures and then compare that to your crop target. And that's how you calculate those deltas and rank and determine your best farm location. And then finally, you really have to make that decision about which is the most suitable cooling technology to manage temperature in whichever inland California zone you select. And again, it's far more complicated than just looking at temperature, but temperature is absolutely a way at least to rule out certain areas like we did with needles and just said, you may have very cheap land. You may see a used greenhouse or a repurposed greenhouse for sale. The price might be right, but if you can't achieve your crop targets and you have some very high cooling deltas, it's probably going to be a loss on your investment. And it's super important. I want everybody here to not have that happen. I want people to be able to look at their climate, select their climate for their crop, and make the right decision and at least have a chance for success. Thanks again for tuning in. We'll talk to you next time in Lecture 4. Thank you.